All right. Gas laws. Okay. We've had them before, had them in chemistry last year. And so gas laws are going to look at things like temperature, volume, pressure, and amount and kind of figure out what those things do. So when we're talking about these variables, amount for gas laws is going to normally be in moles. Temperature is normally going to be in Kelvin, not Celsius, Kelvin. Volume will be in liters. And then pressure is going to be in atmospheres, which are ATMs, or millimeters of mercury. So those are the kind of the units you'll see: moles, Kelvin, liters. ATM, which is atmospheres, or millimeters of mercury, which is kind of a weird older unit, but it still comes up. It's just like if you push down on a container of mercury, how much of the mercury goes up into a device that kind of looks like a thermometer. So don't worry about it. It's just a unit of pressure. Okay, so let's go ahead and fill this in. Boyle's law says that that if you keep temperature and amount the same, volume and pressure have a relationship. Well, they have an inverse relationship, which means that if one goes up, the other goes down. And so they are going to vary inversely, or the key word on that is that they have an inverse relationship. All right. So what happens is if you have a really little bitty container and you put a lot of gas in there, well, the volume of the gas is now much smaller, right? Small container, so the volume is much smaller, so the pressure goes up. So if you take like all of the gas in your house and you put it into like a scuba tank, all the gas in your house in a scuba tank, suddenly the scuba tank has a whole bunch of pressure because all of the particles in your house, all the gas particles, are now in that little bitty scuba tank, and they are all bouncing off and hitting the walls of the scuba tank. So here's your, oops, that's not how we want to do it. Let's go here. So here is our container. So we'll call it a scuba tank. And then those particles are now bouncing off of the walls. And of course, the more and more and more you have, the more bouncing that you get. And so if you put all of the volume of your house, which is a large volume of gas, in a very small container, then it's going to have a lot of pressure. Now, conversely, if you take like a spray paint can and you take your spray paint can, so here's your spray paint can, and you spray the spray paint out like this, well, now the pressure that the particles are at is much lower because, see, they're out in the world and they have a lot of freedom to spread out and move around. So now they're at a much lower pressure. And so you went from a small volume, high pressure inside the spray paint. So inside the spray paint, we would be at a very high pressure and a very low volume. That's inside the spray paint can. And then we let the spray paint out. Those particles are now going to be at a much lower pressure, and they're going to take up a much higher volume. They're going to be able to spread out. Okay, so just a little idea on how that works. Charles' law is going to look at pressure and temperature. And so this is going to be a direct relationship, or directly related. Keyword is direct. That means if one goes up, the other goes up. All right, one goes up, the other goes up. And so that's what we're looking at there. One goes up, the other goes up. And then the Gay-Lussac's law just takes the other variables and it is going to relate them. And so that would be, okay, now what happens to pressure? Oh, don't want that. Want the pen. We're going to look at pressure and temperature. And so it says that it's proportional. And so then this one would also be a direct relationship as well. Okay, and then here we go. Combined gas law is really the only thing that matters. It kind of puts everything into a single formula. So I'm going to write that down. You need to make sure you have it. It's definitely something you want to know. So it's pressure times volume over temperature equals pressure times volume over temperature. Now you can kind of think of it as like these could be ones if you want. Oops, not that. So it's a one. And these could be twos. Or you can think of it as like this is my starting values and these are my final values, right? Either way, it'll work. I just do PV over T equals PV over T. We just have to make sure that we pay attention to the units while we're working on this, right? So units are definitely important, especially that guy right there, the temperature always having to be in Kelvin, all right? Okay. You will never be tested on the names of the gas laws, only on your ability to do problems with them. So never like, hey, define this. No, more like do a problem. Okay. All right. Great problem right here. Just simple, but using some terminology I want you to be familiar with when they do things like factors. How do we figure that out? All right. So factors. So it says a sample of neon gas has a pressure. Okay. So we got a pressure of 5 atmospheres. And when the volume is increased by a factor of 2, its temperature is increased by a factor of 10. What is the new pressure? Guys, this is a fabulous question for a test. So I'm just going to give you a big hint right there. I like to use these kind of questions because IB likes to use these kind of questions, these factor questions. Okay, so first of all, if you are doing something that's talking about a factor, then you are going to have to mathematically put some values in, and you're going to have to come up with whatever your factors are. So when they say factor, they basically, a factor of 2 would be times 2. Okay, so a factor of 2 means times 2. A factor of 10, so this is times 2, and the factor of 10 would be times 10. All right, so what I always tell students is choose the easiest factor you can mathematically. So the easiest factor is this. If you want to do times 10, 1 turning into 10, that is a factor of 10. And that's really easy math. A factor of 2, 1 turning into a 2, is a factor of 2. Choose easy factors so you can do easy math, okay? Easy factors for easy math. All right, so let's take a look here at the actual problem. So we're going to use our formula here. So pressure, volume, temperature equals pressure, volume, temperature. And so we're going to look at this. Well, we have a starting pressure of 5. So let's put that for P. So 5 ATMs. Okay, good. And it says the volume is increased by a factor of 2. So that means I need a starting value. So I'm going to say 1 liter. Okay, I had to put that in. I had to make that decision. But see, starting at 1 and going to 2, well, that's a factor of 2. So I'm going to use that. And so I'm going to put a 2 on the other side like this. See, it went from 1 right here to 2. That's a factor of 2. See, I went up by 2. All right, so now let's look at our temperature. Well, the temperature increased by a factor of 10. Well, how about we make this 1 Kelvin? And then over here, we could make that 10 Kelvin. And that is, again, 1 to 10. That's a factor of 10. See, 1 times 10 equals 10. There we go. That's a factor of 10. So you want to do stuff that's easy. You don't want to do stuff that's mathematically going to give you some kind of difficulty. And now they want to know the new pressure. And so we'll go ahead and put that down as an X. And we'll solve for X. Okay. So notice I set up very easy numbers so that I could do some fairly easy math. Now let's make sure that we know how to do stuff like this. And I'm just going to point out this is cross, multiply, and divide. So here's the X. So we're going to multiply here because that's where all the known values are. So we're going to multiply there. All right, so that's multiplication right there. And then you're going to multiply those three, and then you're going to divide by the other part. You're going to divide by those multiplied together. That's called cross multiply and divide. Cross multiply and divide. So that would be 5 times 1 times 10. See, I'm multiplying those, divided by 1 times 2. It's going to give me a new number. Now notice that you can do all this in your head. So 5 times 1 is 5, right? And 5 times 10 is 50. And then 50 divided by 2 is going to be 25, right? So it says, what is the new pressure of the gas? The new pressure of the gas would be 25 atms, okay? Now, this is a question that you would see on a test. I want you to be familiar with these factor type questions, and the key is just putting in the right values. All right, I'm going to pause it here, guys.